Okay, so in this problem, we're asked to graph this equation, find the vertex, the focus, the directrix, and the focal diameter. All right, now in general, I realize I'm going to give the most general equation for a parabola that has an x squared. All right, and the most general equation is x minus h, quantity squared, equals 4p times the quantity y minus k. Right, so first thing is, if it's a parabola, you want to look, is x squared or is y squared? Clearly x is squared, so we're going to use this particular equation. If y was squared, that's what the next video will be about. Okay, so the x is squared. We can see there is no number subtracted from x. It's really 0. X minus 0 is x squared. So h is 0. Likewise, k is 0, because this is really y minus 0. Yeah? So the vertex is at the origin. It is 0, 0. So now, to figure out, again, this is the general equation if x is squared. So we want to isolate x squared. We want x squared equal to 4 times some number times the y. So let's subtract 12y. So we have x squared equals minus 12y. Now, the general equation is, again, x and k are 0. So our general equation is x squared equals 4p times y. If I plug in 0 for x and h and k. So we want this to be written as 4 times some number so we can figure out what p is. We need to know what p is because it's in all of these other calculations. So this is what I do to figure it out. What I do, yes, we could factor out a 4, but what if this was 10? Yeah, you can't factor out a 4. So what you do is multiply by 4 and divide by 4. That's the same as multiplying by 1. So if I multiply by 4 and divide this number by 4, notice the 4's cancel, and it's the same thing as negative 12. Yeah, it's the same thing. Why did I do that? Because now this simplifies, and we're going to get x squared equals 4 times p times y. This is our value of p. So when I simplify that, that gives us a whole number. It could be a fraction. Like I said, if this was negative 10, we would get negative 10 over 4, which reduces to negative 5 over 2. In that case, p would be negative 5 over 2. It can be a fraction. But this is a whole number. Negative 12 over 4 is negative 3. So we now know what p is. So the focus, again, h is 0 and k is 0. So we get 0. 0 plus p. Let me kind of write this down here. From this, we can see that p, 4py, p is negative 3. So, back to here, 0 plus negative 3 is negative 3. So this is where our focus is located. What's the equation for our directrix? Well, it's y equals k minus p. So in this case, we're going to get y equals k is 0. So we get 0 minus a minus 3, but minus a minus 3 is plus 3. So we get y equals 3. So that's the equation of the directrix. We're going to graph that in a bit. The focal diameter is just the absolute value of 4 times p. 4p is negative 3. 4 times negative 3. That gives us the absolute value of negative 12. And the absolute value of negative 12 is 12. So, let me just recap. Our vertex is 0, 0. The focus is 0, negative 3. The directrix, the equation is y equals 3. And the focal diameter is 12. Now let's put this together in graph. So first of all, whenever we have an x squared, y is equal to an x squared, the graph is going to open up or down. If p is negative, it's going to open down. If p is positive, the parabola is going to open up. Clearly P is negative, so our graph is going to open down. Let's just put a couple values in here. So our vertex, as we know, is 0, 0. So that's why the very top point of the parabola is our vertex. If the graph opened up, the very bottom point is the vertex. So that's 0, 0. Well, what is the focus? It's 0, negative 3. 1, 2, negative 3. Right here is the focus. What is the directrix? Y equals 3. 1, 2, 3. It's always going to be a mirror image of this, okay? The same distance, right? That's our 3. But the graph of y equals 3 is just a straight line. Y equals 3. This line is the directrix. And the focal diameter, that's a number, that's equal to 12. It's called the focal diameter. And last, let's just put a couple numbers in here. Notice if x was positive 2 or negative 2, when I square it, positive 2 or negative 2, I get 4. And when I divide, I get negative 1/3. So this is not to scale. If this was negative 2, this would be down to, let me kind of get this more to scale. This would be negative 1/3 right here. Yeah? So if I plug in positive 2 or negative 2 into here, plus or minus 2, and square that, it's equal to 4 times negative 3 times y. Why did I pick positive and negative 2? Because in my mind, when I square it, I get 4, and it's just going to cancel. That's the only reason why I picked that. So when I square a positive or a negative, it becomes positive. When I divide, we get y equals 4 over 4 times negative 3. The 4's cancel, and we get negative 1/3. So that's where we get our negative 1/3. So this is going to look like that. And so on and so forth, you could figure it out. But negative 3, I guess this is 1, 2, it's really down here. Likewise, to scale, our directrix is going to be more up here, right? But that's the idea of sketching a graph when you have an x squared. It's going to open up or down. And these are our formulas for finding the vertex, focus, directrix, and focal diameter.